All right, so this is how we use the energy in the US. By we, I mean in the US. Okay, so about 28% is used for transportation. That's mostly gasoline and jet fuel. 28%, so more than a quarter of our energy consumption is just transportation. It could be much lower. It's much lower in countries like Germany, for example, where they have a lot of infrastructure in trains and mass transit, buses, subways, this kind of thing, S-Bahn, U-Bahn, what have you. And so it's a much smaller part of their energy consumption. In many countries, it's like that. Also, though, the US is huge. It's not so convenient for us to go coast to coast with trains for passengers. On the other hand, you could say, well, gee, but in this certain region, why don't we have lots of trains? So, not saying which one's better or worse, but our numbers here are much higher than a lot of other industrialized countries, mainly because of, one, our size, and two, lack of a lot of public transportation. So this could be smaller, or it could be bigger, actually. So we use 40% of our energy to generate electrical power. Does this make sense? We're using energy to make energy, what? Well, what we're talking about here is for example, if we're talking about like non-renewables or whatever, we're using not jet fuel, gasoline, natural gas, whatever, to generate electrical power. So it's kind of like you're putting energy in, you're getting energy out, but you don't get out as much as you put in. And this is what this is reflecting. So if I have so many kilowatt hours equivalent of natural gas that I'm using to generate so much kilowatt hours of electricity, there's loss there. So I lose a lot of energy in this conversion. And that's what this 40% is all about. Okay? 20% of our energy we use for direct heating. You burn coal, you burn natural gas, what have you, to directly heat, say, your home. Okay? To directly heat this building. 32%, about a third of our energy consumption only is used by industry. Now that adds up to 120%, and it means there's some double counting coming on. So for example, industry, in addition to using energy to run a machine, is using energy to heat the plant, to heat the building. So there's double counting going on. That's why it adds up to 120%. And these are our sources of energy. Now these numbers, I have to warn you, are not current, okay? With the oil fields and gas fields opening up, particularly in North Dakota, these numbers have changed a bit, all right? So we can, when we get to those sections, I'll give you improved numbers, but they're still not way off, okay? So about 30% of our energy source is from imported oil. 11% is from domestic oil. Now, you got to be careful here because for the purposes of bookkeeping, more for political reasons than anything else, we consider Canadian oil to be domestic. Everybody likes to say that, whether you're a Republican or a Democrat. Everyone likes to say, you know, we're self-sufficient in oil. Not self-sufficient, but we're using a lot more domestic oil, but a lot of that oil that we're claiming is domestic is actually from Canada. 24% from coal, 19% from natural gas, which is more or less methane. But this is going up for two reasons. One, fracking is cheap. It's a method of extracting natural gas. We're getting natural gas from a lot of places that we didn't get natural gas from before because of the technology. But the other thing is that it's cleaner. It's not clean, but it's, as you hear on TV, but it's cleaner than other sources like coal, less polluting than coal. So for those two reasons combined, our use of natural gas is rapidly rising. We get about 8% from nuclear. That's been stable for a really long time. And we get about 8% from others. Geothermal, biomass, wind, hydro, solar. And we'll talk about all of these in turn. And there's what I was saying, political reasons we don't count Canadian oil as imported. Okay, so here's the cost of energy per kilowatt hour. And these aren't new numbers, so they could vary a little bit. You can go on the web if you want to get up-to-date numbers, but they're not far off. Coal's about 0.4 cents to 0.8 cents per kilowatt hour, which works out to be about $40 to $80 per ton. A ton. ton of anything for $40 is cheap, I got to tell you. Natural gas, 3.4 cents per kilowatt hour. Remember, our electricity is typically about 10 cents per kilowatt hour. So this is about 3 times cheaper than electricity per energy unit. So $10 per million cubic feet. Wow, that sounds pretty cheap. Gasoline, that, if it's $3.70 a gallon, and it's typically cheaper than that right at this moment in Manhattan. On the other hand, when I was in Lucas, Kansas, it was almost exactly $3.70 a gallon last weekend. That works out to be about 11 cents per kilowatt hour. Car battery, 21 cents per kilowatt hour. Computer battery, about $4 per kilowatt hour. A AAA battery, really expensive. A disposable, this is a disposable AAA battery, about $1,000 per kilowatt hour. These are numbers you really need to know, okay? A horsepower is essentially a kilowatt. For the purpose of this class, a horsepower is a kilowatt. Kilowatt hour is 1,000 food calories for the purposes of this class. Kilowatt hour is, I said that one, average home uses 1 kilowatt. Okay, this is really important because we can discuss all kinds of things if we have some numbers to work with. So we'll work with this nice average number. This is something you just have to be able to pull up. Average price of electricity in the US. This is also a very useful number to memorize because it helps you make quick calculations. 10 cents kilowatt hour. Okay, I want you to know these two. We won't use all of them, but there's no reason not to know them. It's just a little bit of memorization. We do use metric occasionally, even in this class. So these are prefixes. Like if we were talking about a watt, you could have a petawatt or a terawatt or a gigawatt or a gigawatt. Some people say giga, some people say giga. It's your choice. Megawatt, kilowatt, hectawatt, da-da-da-da, okay? And for anything else you're talking about, if you're talking about grams, you could have a kilogram, a decigram, a centigram, a milligram, a megagram. Don't see much megagrams, but you could in principle. So in my laboratory downstairs, we make terawatts of power per square centimeter. Sorry, I'm wrong. We make petawatts of power per square centimeter. Very powerful lasers down there. So you need to know these things. By the way, talking about the pronunciation of giga, you're all familiar, I suppose, with the movie Back to the Future. Have you ever noticed in there's a scene where Marty goes and meets Dr. Brown in the past, and Dr. Brown's just freaking out at the amount of energy it would take to power this vehicle, since they don't have any nuclear fuel. And he's saying whatever the number is, 22.7, what's he saying? 22.7 gigawatts, no, 22.7 gigawatts, 22.7 gigawatts, where are we going to get that much power? So he's saying gigawatts, and Marty says, Doc, what the heck's a gigawatt? So if he's never heard of it, how did he pronounce it differently? So anyway, okay, blooper. Geeks have to pay attention to that kind of thing. Okay. So gigawatt. You can say giga, I can say giga. That's it. Questions?